So in this video, we are going to walk through the KAIST repository and what's the main function and what's the homework you're gonna implement. So this is the README of the repository, and in order to work on this compiler, you first need to install what is called Rustup. Just go there, and there is an instruction to install Rustup. Rustup is basically a installer for Rust. So please do install Rust with this Rustup. And the first thing you can do about this repository is building. So for example, you can type cargo build in this repository, and it is compiling the repository. So, and you can build a repository in release mode like this. So it is building the repository like this. And you can run the compiler by typing cargo run blah blah blah. After compiling this, then it is going to, because of this -h option, it is going to show you some options of this compiler. So you can put the arguments appropriately to see, let compilers do what you want to do. So for example, if you want to just parse these examples slash Fibonacci.c and just print the parsed code, you can just do it, and then it is going to read this example slash Fibonacci.c file and then convert it from string to AST, and then convert it back to AST to a string, and then write it to the console. So let's see what was looking at in the repository. I mean, in the example, it looked like this. It is a Fibonacci function that is computing using some recursive function, and this command is basically parsing this string and then converting it back to string and then writing it. So you can see that it is a little bit different, right? So for example, in this condition, the original file has only one parenthesis, but the printed version has two parentheses, like this. But it's okay. So we are going to allow this kind of slight variations when evaluating your homework. So this is basically printing option, and let's go through the README. You can do IRGen, for example, like this. So this is basically the second homework, and you can just compile it, but it is going to say it is not yet implemented because I didn't implement yet. And you can add this release flag to execute this program, execute this compiler with a release build. You can also test your repository by cargo test. Then it is going to test your development using some existing test code, and this is testing your development with release mode. And for the homework 1, the particular test you want to implement use is these test examples right C. So it is testing many examples in this repository to see if your printer, AST printer, works okay. You can also fuzz your compiler after installing make, CMake, and Python software, which is already installed in your server, and you can install them on your machine as well. You can fuzz your AST printer by typing this. So it is executing 10 times. It is randomly creating 10 test cases and see if your printer works okay for the randomly generated C files. And if you didn't specify this n, then it is going to do it indefinitely. So that is basically how to test your homework. And let's walk through the repository source code. The first thing to do, or the top level thing to execute your compiler, is in bin and kek. Kek contains the main function, which is what is executed using this cargo run. So if you run this cargo run, this main function is executed. The first thing to do is parsing the argument and getting the input. And it first parse the given C string, then you don't need to care about this because it's already taken care about in the skeleton code. And you're going to print it if you are giving the print option. So if the argument has this print option like this, or in short it is just -p, or in long it is minus print, then it is going to execute this write C. You're going to execute this write C. That is actually printing the parsed input into the console. And blah blah. So for the purpose of the homework 1, you only need to care about this because the others are for the later homeworks. And let's see what's going on in this write C. So in write C, the main function that is executing is this write line for the translation unit, because in the main function you are going to call the write line for the translation unit. And this is filled with this like this in your homework, and you need to implement this. That is the homework 1, and submit this file to the gg.kaist.ac.kr. So this is my implementation, which is iterating through some translation unit external declarations, and the write line function for this external declaration is in turn defined like this, and this function for declaration is in turn written like this, and blah blah blah. So you should recursively walk through the AST and implement the print function for each of them. So one more thing to discuss about this write line function is that the self-is translation unit. You're going to be given the translation unit, and you're going to write it to what is called this write. You can just use it like this. I mean, you're going to write to this write, which is just you can think of this as a sync of the stream. In C++, it is cout in C++ or something like that in that is in Rust. So you're going to be given what you're gonna print and where you're gonna print. And one more thing is given, that is indent, which is the indent level of the thing you're going to print. For example, if you want to write a block like this, suppose that you're trying to write something like this in the screen. I mean in this write line function. Then you need to first draw this bracket, and then your content, and then your ending bracket, right? But it may be the case that this block is inside another block. Then you need to print this with an indentation. You need to write down the spaces for the indent. The number of indentations is given as a variable here. So if it is 0, you're going to start a line with no spaces. And if indent is 1, then you are going to you have to write down spaces, for example, 4 spaces at the beginning of each line. And this should have an indent level 2, and it is going to print 8 spaces at the beginning of each line, and blah blah blah. So this is basically the meaning of this indent variable. And somewhere you have to recurse into the substructure. For example, here in the writing function for statement, and if it is a labeled statement, you are going to recurse into one level deeper with this inner statement, basically. But here you are going to use indent level that is one bigger than the original one, because you want to indent basically the inner content of this. And here is the same. If you have a compound, compound is basically a block, and you need to write down the content, the inner content, with one indentation level up, and blah blah blah. So basically, you are going to implement this function, right line. But at some point of time, you're not going to, for some small structure, you're not going to print them in line. You just write it in a single line or a single string. In that case, you're going to use write string. For example, for a declaration, you're going to first write the indentations, and then you're going to write down the inner declaration inside it. So it is just writing down the string instead of a line or instead of a right line. So because we are not going to indent on yourself, you're going to just convert some structure into a string without any spaces or indentations inside it. But so in order to implement this write line function for declaration, you first manually insert indent, and then you're going to write down the inner content later. So I already implemented the write function in this way, and as a result, we can compile this Fibonacci function like this. So it is first parsed into an AST, then it is written using these functions, write line and write string functions. It is written into this form. So please write down this write line function for the translation unit, which is the top level definition of a C source code, and then it is going to be automatically evaluated using the test functions. So here is an example of test function one more time. So this test examples write C is executing these write line functions for many times and see if it is it is executing as expected. So let's see the test code, which is here. So test examples write C function is iterating through all the files inside this directory, and it is executing what is called write C test, which is defined in write C test here. So what it does is that if it is given a AST translation unit, then it first write it to a file using the function you implemented, write C, and then it is parsing again. And we're going to see if the results are the same. So here is the scheme. So you're given a C in string, and then you're going to parse it into a C in AST, and then you're going to write it down, and then you're going to parse again. And let's name it A, and let's name it B. And we are going to check if A equals B. So assuming that the parser here, parser is already given by the way, parser here and parser here are acting correctly, then it is checking if your printer is acting okay. So basically that is how it is tested, how it is testing your write C. And this test example write C is executing this test function for each of the examples in this directory. So there are many C files in this directory. For example, a line of blah 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 blah, and it is going to see if it is okay. And the fudger is randomly generating the source code and do the same thing, print and parse, and see if they are the same, blah blah. So this is basically the homework, and please do it and submit to gg.kaist.kr.